Everyone, just checking everything's working fine. Let me know you can hear me okay by writing a message on the chat function. I'm trying few new features out, and so let me know if there's any problems with our either our video or my sound or anything else actually. So it'd be good to kind of see any comments there so you can let me know you can hear me okay. And I'm going to go through quite a few different questions from our first revision mat. So hopefully everyone's looking forward to that. I am definitely looking forward to meeting some new faces. Last year, I think quite a few of us who had children in year five that were going through CSSE attended quite a few of our lives and our other sessions as well. So let me see if this works well or not. I've got a few things here. Let's see if that move that there. Well, okay, great. I can finally read some of your comments, which is great. Hi there, Moni. Hi, Sheena. Um, You're fine, Sheena. I'm sure you're just exaggerating there. I'm sure you're brilliant at maths, just like you've been brilliant at creating those novels of yours that everyone's been very excited to go through over the last year or so. Hi, Abby. I'm glad everyone can hear me. I think we'll get started now. So this is the typical setup I have. I have myself here, but I suddenly swap over to my iPad, which is something you should be able to see anytime soon. And there we can kind of go through different questions together. So for us, we're going through the revision mat. We've got 9 questions I want to go through with you and take you through. Now, if your children are there, they can participate, they can answer questions, that's fine. If you want to answer for them whilst they kind of reply, that's also fine by me. Just let me know if you have any questions by writing a Q at the beginning of your message, and that way I can quickly scan and see there's a Q there, that's a question, I can kind of go through that question. So let's get started and go through the first question. So if you don't know already, there's a revision mat that I've released last week. I think it was a Friday that I released the revision mat, and I promised everyone that I'll go through the revision mat this week, which is now today, Thursday. Same thing will happen tomorrow. I'll release another revision mat second week, and then I'll go through it again the following week, and that will keep happening until I run out of revision mats and I run out of time to do these Facebook Lives. So the first question on the board, it's 12 and a half times 8 divided by 24 in brackets divided by 48. So typical kind of bid maths type of question. Can our children multiply decimals, divide by another number within a bracket? What do they do first? What do they do second, etc.? So bid maths wise, brackets first. So 12 and a half times 8. If we are quite confident with our maths, we could do 12 times 8. 12 times 8 is going to be 96. And then half of 8, half times 8, or 8 lots of halves, is going to be 4. 8 lots of halves is 4, plus 96 is 100. So 12 and a half times 8 is 100. 12 and a half times 8 is 100 divided by 24 divided by 48. Now, a lot of children might get confused here, and they might actually do 48 divided by 24, which wouldn't be right, okay? Because that would be 2, right? And so that's not what we're looking for. We're looking for 24 divided by 48. So what we do at Singapore Maths Academy is to remind our children that when you've got a division like this, if you're a bit unsure, if it looks a bit off, if it looks a bit funny, you can actually think of it as a fraction. So 24 over divided by 48 can be thought of as 24 over 48. And sometimes that helps us to cancel things down and get to where we need to go. Okay, so 24 divided by 48, 24 over 48, that's the same as a half. So what we're trying to do is 100 divided by a half. And that would be our question, the final part of our question. 100 divided by a half. Now, a lot of children actually will think half of 100, which would give you the wrong answer. 100 divided by a half means how many halves are there in 100? So the typical question I would go through is, if you've got one whole, how many halves are there in one whole? There are 2 halves in a whole. I've got 100 wholes. and therefore it's going to be 2 times 100, which is 200. So the answer to this question is 200. So typical places that children make mistakes here are, firstly, if they are not confident at multiplying a fraction or a decimal. So that's something that you can check out with your children to see if they are confident with that. So this question brings out a few things for you as a parent. If your children are struggling with this question, if they got this one wrong, where are they getting it wrong? Are they getting it wrong in multiplying decimals? Are they getting it wrong in dividing 24 by 48? Have they got a misconception thinking that 48 divided by 24 is easier, so I'll do that instead, and that will be the same answer? Is that something they've done? If they haven't got 100.5, then you already know that the mistakes happened, and therefore they've made a mistake in the bracket somewhere. If they have 100 divided by half and they write the answer as 50, then they've got another misconception, which is that dividing by a half is the same as dividing by 2 for them, which is not the case. Dividing by a half is the same as multiplying by 2. And so that's something else that you can see from their working out whether they have any of those misconceptions. If they have, then you know how to tackle that and you know what specific misconception that is as well. So hopefully that helps you to identify any misconceptions there. So the final answer there is going to be 200. Oops, not like that. That's a bad idea. There we are, 200. Right, so the next question, 1 and 5/6 divided by 22. So typically dividing a fraction, it'd be a good idea for us to convert that mixed number into a improper fraction instead. So 1 and 5/6 can be written as 1 times 6 is 6, that's 6 makes a whole, plus the 5, that's 11/6. So we could do 11/6 divided by 22. Now, typically, I don't recommend my children always jumping to the flip the second number over when you're multiplying. So when you're dividing a fraction, flip the second number over and then or find the reciprocal is a more mathematical term. But a lot of children say flip the second number over and multiply. That's not what I always recommend. So for something like this, I know, for example, 11/6 divided by 22, 11 and 22, I know that 22 divided by 11 is possible, and also 11 is half of 22. So what I might suggest to my children is, can you think of an equivalent fraction? 11/6 is equivalent to what? Oh, is equivalent to 22/12. If I multiply 11 by 2 is 22, 6 times 2 is 12. So 11/6 is equivalent to 22/12. And so 22/12 divided by 22, that's quite simple, right? It's like 22 cars divided by 22 or 22 sweets divided by 22 people would be 1, right? And so 22/12 divided by 22 would be 1/12. And so our answer here is 1/12. You can use the other method where we say, oh, 22 over 1 is the same as 22. So we can do 11/6 multiplied by 1 over 22. Why does that work? Because dividing something by 22 is finding 1/22, that's a word, of something, right? So dividing something by 4 is the same as finding a quarter of something, right? And so that's why this works. And so what we can do is we can cancel these two down. That becomes 1, that becomes 2. And you've got 1 times 1 is 1, 2 times 6 is 12. And you get the same answer, which is 1/12. You can do 11 times 1 and 6 times 22 and cancel down as well. But this would be a more efficient way of getting 1/12 for the answer. So again, if your children, so looking at it now, the parent, talking to parents now, talking to children, these are two methods that you might want to choose. I prefer this second method because I feel it's much more efficient with my time. Because part of the CSSE and 11 plus in general actually is making sure you utilize your time. If you're not utilizing the time here, or if you're taking too long on certain questions where you could have saved a lot of time, then obviously that's going to have an impact further down the line where you don't have enough time to tackle some of the more challenging questions. As a parent, you've got to think about, does my child know how to divide a fraction by a whole number, or even a fraction by a fraction? And what do they need to know Okay, do they know, do they understand something, or have I just told them to memorize flipping the second one over and multiplying? Because if I've done that, most likely with challenging questions, they're going to not do as well because they can't always memorize these sort of things. But if they've understood that actually if I have an equivalent fraction that can be easily divisible by 22 in this case, 22 is divisible by 22, so 22/12 is easily divisible by 22, and I get 1/12. That will make more sense to our children. So just bear that in mind as well. If your tutors or if yourself, if you've been teaching your children and you haven't looked at reasoning and you haven't looked at understanding maths, they will find the more challenging aspects quite overwhelming in most cases. Question 3, convert to centimeters, 3.85 kilometers. I've put on a little chart here. 1 kilometer is 1,000 meters. 1 meter is 100 centimeters. So 1 kilometer in terms of centimeters is going to be, what we're going to do is we're going to do 3.85 first. We're going to change that into centimeters. 3.85, well, into meters, excuse me, first. 1 kilometer is 1,000 meters. That must mean I have got 3.85 kilometers. So I have to multiply this by 1,000, right, to get it into meters. So I've got 3,850 meters. So 3.85 kilometers is 3,850 meters. But we're asked to convert to centimeters, right? And so I know that 1 meter is 100 centimeters, and it said 1,000. 1 meter is 100 centimeters. So I have to multiply 3,850 meters by 100, and I get the answer as 385,000, which is 385,000 centimeters. So 385,000 centimeters is equivalent to 3.85 kilometers. Right, going on. So this is just an equivalence question. Your children need to know some basic equivalences like kilometers to meters, centimeters to meters, millimeters to centimeters, and so forth. If they know those, they can get to other questions as well quite quickly, long as they know some basic conversions. If they don't, sometimes the question does tell you the conversions, but in general they don't. So it'd be good for them to know some conversions. Question 4. James shares his sweets so that every time Eva gets 1 part, Sophia receives 3 parts and Trent receives 2 parts. Altogether, Trent and Sophia had 90 sweets more than Eva. How many sweets did James share? Quite a tricky ratio question. So the language used here is for every time, right? Every time Eva gets 1 part. So every time Eva gets 1 part, Sophia receives 3 parts and Trent receives 2 parts. And so that language for every, for example, is another way of putting it, is related to ratio. So if you're not comfortable, if your children are not comfortable with hearing that language and associating that with ratio, then they can have problems. Okay, so bear that in mind. The language there is ratio related. So the way we would go through this question at Singapore Maths Academy would be for us to go through using something called the bar model approach. Let me know if everyone can hear me. Just give me a thumbs up or a comment, just so that I am quite happy to continue and that no one is missing out on this and I'm not just talking and no one can hear me, which would be very, very frustrating, right? So just let me know if you can hear me. That'd be really helpful for me as well. So the way we would go through this at Singapore Maths Academy is through a world-class strategy called the bar model approach. Not many tutors know about the bar modeling approach or use the bar modeling approach. Only a few handful of tutors do. And it's a phenomenal approach. It's made Singapore one of the best known countries in the world for maths education for the last 30 years. So it's something very, very useful. So here, what I would do is I would write down, okay, Eva, let me do that again. Eva has 1 part. So I'll do E for Eva, and I'll show a bar to represent Eva. Then it says Sophia has 3 parts. So Sophia has got 3 of these equal parts. 1, 2, 3. And Trent has 1 part. So actually, no, not one part, two parts, excuse me. Trent has two parts, something like that. Okay, so I've got very roughly sketched, doesn't have to be a piece of art. It just has to be very, very clear, as equal as possible, I would say. And so I've got something like this. Altogether, Trent and Sophia had 90 sweets more than Eva. If we look at the bar that I've drawn, if we look at the part that Sophia and Trent have more than, Sophia's got 2 bars more than Eva. And Trent has got this 1 bar more than Eva. And it says altogether, Sophia and Trent have got 90 more. So these 2 bars and this bar here altogether, these three equal parts have to equal to 90. Because it says Trent and Sophia had 90 sweets more than Eva altogether. And so those 3 parts equal to 90. That means each part must be 30, 60, 90. Each part must be 30. And therefore, all of these parts, because the ratios, all of them are equal, all of these parts are equal to 30. And the question is, how many sweets did James share? So all of these are the sweets that James shared. And so you can see it's 30 for Eva, 90 for Sophia, that's 120 so far, and 60 for Trent, so that's 180 sweets altogether. So James shared 180 sweets altogether. So hopefully that made sense. Let me know in the comments if you can see the bars helping your child or helping you even as a parent. Did it make sense the way I went through that? Because a lot of people might jump to algebra. And algebra, I love algebra, one of my favorite topics in maths, if not my favorite topic in maths. But I can definitely tell you from my experience, and I've been teaching maths since 2004, and even before that, actually. So a long time now, I feel very old saying that. But I know from experience, not everyone enjoys algebra. And so what we need is that bridge from maths that they're used to at primary level to algebra. That bridge would be absolutely phenomenal to use the bar model approach. So just bear that in mind. If your child is struggling with algebra, it's okay. Try to use a visual approach like the bar model approach to get them to see why the algebra works later on, because that is the most important part, is getting your kids to understand. It's not forcefully making them get the answers correct, because that's not going to be very useful for them in the future. But understanding maths, that's going to be a phenomenal, confidence boosting, moral boosting experience for any child. So let me go into question 5. A pack of 15 ballpoint pens costs £3.75. A pack of 3 ballpoint pens costs 90p, and a single ballpoint pen costs 33p. What is the maximum number of ballpoint pens you can buy? £5. So this is just a case of a money question, and making sure that children can add money together and realize how many ballpoint pens, the number of ballpoint pens that they can purchase. So I know already that I can buy 15 ballpoint pens for £3.75. So I already know I'm going to have 15. Okay, 15 for £3.75. Then I know I can add another 90p actually. If I add another 90p, then that's going to be another 3 more ballpoint pens. So altogether, I've got, let's see, if it's £1, it'd be £4.75. It's 10p less, so it'd be £3.65. So £3.65 is how much, how many is it? £3.65, £4.65, I should say. £4.65 is how much I've spent so far. Now, I can't buy another 3 ballpoint pens. That'll be 90p. That wouldn't be feasible for me. I don't have as much money. And so I definitely can't buy a 15 pack because that's £3.75. But I might be able to squeeze in a single ballpoint pen. That's 33p. I've got 35p left. So I can add 1 more ballpoint pen at 33p, and I will have £4.98 spent. And I would have 15 plus 3 is 18 plus 1, 19 ballpoint pens. The maximum number of ballpoint pens I can purchase is 19 ballpoint pens. And so that's another way to kind of look at this question as well. B, what is the most you would save by buying a pack of 15 ballpoint pens? So I know a one pack of 15 is £3.75. To buy 15 ballpoint pens with three ballpoint pens in them, I would need 5 of those. So 5 packs of threes, 5 packs of threes is going to be 5 times 90. 5 times 90p, which equals to £4.50. So I know that's going to be £4.50. But is that the most expensive option for us? Well, I know a single ballpoint pen, right? One ballpoint pen is 33p. And so if I did 33p times 15, that will give me how much the cost of 15 would be if I bought individual ones. And so if I did 10 times 33, that's £3.30. I might do this, £3.30, add half of that, which is £1.50 plus 15, £1.65. That's how much it's going to cost me to buy 15 individual ones, right? So £1 plus £3 is £4, and 95p, right? Oops, 95p. So £4.95 is how much it's going to be for 15 single ballpoint pens. So what do I do next? Well, I know that buying a single pack of 15 is £3.75. The most expensive way I can buy 15 is £4.95. So the maximum I would save, the question is what is the most I would save? It's going to be £4.95, excuse me, take away £3.75. Right, that's going to be £1 and 20p. The total that I'm going to save, £1 and 20p. If you have any questions, feel free to ask away. It'd be great to hear from you. I haven't looked at all your comments, so I'm just going to go through them very quickly now. I can hear you. Yes, really helpful. Thank you, Naga. Sharif says yes. Agnes got a big message here. Amazing tutorial as always. Thank you for your time. Thank you so much, Agnes, for your lovely comments, and everyone else as well. Okay, so I think everyone can hear me well, and they are hopefully benefiting from this session. Okay, so moving on to question 6. Okay, this was a bit of a tricky question for quite a few of my students as well. So what I do is I not only give this out free to you, but after making these, I make sure our own children have first go at looking at these questions, and making sure that they know what they're doing with these questions as well. So that's our one-to-one students now. Most of our group students have gone off for a break. And so, yeah, if you have any inquiries about your children, smaller children, whether they're in year 3, 4, 5 or 6, or even GCSE maths, and even A-level maths, actually, we cover all the range of maths up to A-level. So do contact us for any of your maths needs. Question 6, a 256 bus arrives at Stamford Hill bus stop every 8 minutes, whilst the 106 bus stops at the same bus stop every 12 minutes. So you've got 256 every 8 minutes. So our driver do this 8, 16, 24, and it goes on. And the 106 every 12 minutes, so it's 12, 24, 36. And I can see that both of them arrive at the same stop every 24 minutes together. Okay, they both arrive every 24 minutes together at the same stop. So the question is, if both arrive at the bus stop at 8:07, how many times will both buses stop at the bus stop together after 8:07 a.m. and before 9:30 a.m.? So that's going to be 8:07 to 9:30 is going to be a total of 1 hour. 1 hour would be 9:07. Add 3 minutes would be 9:10. 20 minutes, so 1 hour and 23 minutes. So in a space of 1 hour 23 minutes, how many times are they going to be joining each other on the bus stop together? Okay, going to stop rather at the bus stop together. So I know after 24 minutes, it's going to be once, 24 minutes. I have to kind of think about how many times 24 goes into 1 hour and 23 minutes. So 24 means 48, and then it's going to be, that's twice. and then it's going to be 48 add 4 is going to be 52, 62, 72, 72 minutes. That's going to be 3 times. And I know 1 hour, 23 minutes is actually 60, 70, 83 minutes. And I know that the next time, next 24, if you add another 24 minutes there, it'll be 76, 86, 96 minutes. And so that won't be possible. So it'll be 3 times. Okay, so how many times will both buses stop at the bus stop together? It'll be 3 times that they'll stop at the same bus stop together. Question 7, tricky one. What methods would we use for this? You might be asking yourselves, how can my children be the most efficient at solving this type of question? Well, what would you do? Would you convert the 5/8 into decimals? So most children do this. And this is not, I wouldn't say this is the most efficient. They'll do 5/8 is the same as 5 divided by 8. And so what would they do? They'll do the bus stop method, 5 and 8, and they'd work out that this is going to be equal to 0.625, for example. Okay, that's one way of working this out. Okay, that's not the most efficient way. I would probably expect my children to know that 0.75 is 3/4, right? So 6 and 5/8 take away 1 and 3/4 might be a more efficient method to solving this question. Okay, and so that will be another way. You can use either method, but that would be probably the more efficient method for this. So you've got 6 and 5/8. You can convert that into equivalent fractions as well. So 3/4 can be 8ths, for example. So you can convert this into 6 and 5/8, take away 1 and 6/8. And so you can see that I can take 1 away from 6 and 5/8. Okay, I can take that 1 away from 6 and 5/8, which is going to be 5 and 5/8. Take away 6/8. I know that I can take 5/8 away from here. So it becomes 5, take away, I still have to take away 1/8. And so 5 is the same as 4 and 1. And 1 is the same as 8/8. And so I can take away 1/8 from here. And then you're left with 7/8. And so you're left with 4 and 7/8 as your answer. So that's a one way you can break down this question much quicker than using very formal methods. Formal methods are important to know, don't get me wrong. They are very important. We teach them all the way through Singapore Maths Academy. But one of the things we've got to teach our children is working smart. You know, that doesn't mean taking shortcuts without understanding. That's not what we teach at all. We're really against shortcuts. But what we're talking about is reasoning skills. Reasoning skills is such an important part of understanding maths. Okay, going to question 8. 12 gamers take 6 hours to build a mansion on Minecraft. If they all work at the same rate, how long would it take? 9 gamers to build. How long would it take? 9 gamers to build the mansion. So this is a question. The topic is inverse proportion. Rather, I've been saying the word inverse operation too many times in my life, right? So inverse proportion is what I meant to say. So this is the way I would solve this question. I would write it out exactly like this with my own children. I would write 12 gamers. Oops, have I done something there? Can you see everything there? Okay, yeah. So I've got question A. What happened there? Question A. I've got 12 gamers. I'm going to write G for... I'm going to write the whole thing, actually. 12 gamers take 6 hours to make one mansion. Okay? One mansion. And so the way I would think of this is, okay, 12 gamers take 6 hours. I'm trying to work out how long it would take for 9 gamers. Now, 12 and 9, they don't go nicely. But if I divide this by 4, then I've got 12 divided by 4, 4, 8, 12 is 3 gamers. So now I've got 3 gamers. 3 gamers wouldn't take a third of the time. It would take 3 times longer, right, than 12 gamers. There are fewer people. That means they have to do more of the work, right? If they work at a steady rate, then that means that I have to do this. I have to do 6 hours times 4. I've divided by 4 here, and I have to multiply by 4 here. Okay, so I've divided by 4, but now I have to multiply by 4. And so here, this would be 6 times 4, 6, 12, 18, 24. 3 gamers would take 24 hours to create the same mansion, one mansion. And so, what's the next step? Now I can see that 3 times 3 would be 9 gamers. 9 gamers would take, would it take 24 times 3, class? No, it wouldn't, right? That wouldn't make sense. If 3 gamers take 24 hours, 9 gamers would take less time than 24 hours, right? I have to find a third of 24 hours because I've got 3 times more workers. So 24 divided by 3 is 8 hours. And so 9 gamers would take 8 hours to complete this mansion. So the first question, 8 hours. The second question is where we have to think about how long it would take for 15 gamers to build 2 identical mansions. Okay, a bit more tricky this one, right? But I'm going to stick to 1 mansion for the time being. I want to know how long it would take 15 gamers to do just 1 mansion. Okay, let's see how that goes first. 15 gamers to build 1 mansion. I know I've got 3 gamers here. 3 gamers takes 24 hours, so 3 times 5 is 15 gamers. So 15 gamers would take how long? They would take, I've done 3 times 5 is 15, so I have to do 24 divided by 5. That's how long it would take for 15 gamers to create 1 mansion. 24 divided by 5. 24 divided by 5. What's 24 divided by 5? That's the hard one, right? 5, 10, 15, 20. That's 4 hours at 4 4/5 of an hour. Okay? 4 4/5 of an hour to make 1 mansion. Does that make sense, firstly? Well, if it takes 12 gamers 6 hours, it must take 15 gamers less than 6 hours. So 4 4/5 of an hour seems like a reasonable answer. Okay? Seems like a reasonable answer. So I think we've got 2 questions. Can you go through question 6 again, please? And SK Gill says, can you go over the question with the bar chart? Bar chart? We have got bar chart so far? I can't remember having a bar chart. Oh, do you mean the bars? Hey, question 4. Is that what you mean, SK Gill? Just let me know. I don't think we've got bar chart, have I? No, we haven't got any bar chart questions yet. But question 4, we did use bar models, so I don't know if that's what you mean. So we can go through that in after we finish question 9. Okay. So where were we? Okay, so 15 gamers takes 4 hours and 4 4/5 of an hour to make 1 mansion. So the same 15 gamers, if they have 2 mansions, 2 identical mansions, then they'll take double the time, right? 4 4/5 times 2, which is going to be 8 8/5, right? 8 8/5, which is going to equal to 9 wholes and 3/5. 9 3/5 of an hour. If you want to change that into minutes, we got to make sure we change 3/5 into minutes. So if this question doesn't ask us to do that, so we can say 9 3/5 of an hour. Or if we want to change it into minutes, we know 1/5 of an hour, which is 60 minutes, is equal to 12 minutes. And so 3/5 of an hour will be 3 times that, which is 36 minutes. And so you could write 9 hours and 36 minutes as another way of writing the answer down. Okay, I think this will be available live after we finish this session, Asma, so you can have a look. And the final one, order smallest to largest. I think this was probably the more simplest question possibly out of them. Maybe not. I don't know. You can decide that. And that's to kind of make sure that your children know their place value. Now, this is our first revision map. Tomorrow's one is going to be a stinker, as they say. Is going to be challenging. Okay, so if this one was challenging, then tomorrow's one will be very challenging. Okay, we're not trying to make the most challenging one. We're not doing that. We're trying to be realistic with the CSSE. From 2019 to 2022, some of the CSSE questions have been really challenging, really challenging. And so we're trying to replicate, not just like copying. I've seen some of the other papers, they just pretty much copy the same sort of questions, change the numbers. We're not trying to do that. We're trying to use our experience of maths education from primary all the way to secondary for the last 20 years or so. And also, on top of that, I'm an author myself of assessment books, so I know how assessment works more than others. And so we've used that experience to kind of create these CSSE questions for tomorrow's session, which are challenging, but really we feel realistic in terms of the CSSE. So let's finish off this question and we'll go back to one or two of the other questions that some of us have asked for. It says here, order the smallest to largest. Firstly, all of these values, if we zoom in here, all of these values all start off with 0 point. So there's no holes apart from this one, which has got one hole. So I already know that must be the largest value. So 1.02 is the largest value there. So then we have to look at the others. Okay, so we're looking at the place values again. This has got a 1, this has got a 0, this is a 1, this is a 0. So I already know that these two must be the least, one of these two must be the least two, because others have got 1/10, right? The next place value, 1/10. And so these two haven't got any tenths, so these must be the smallest figures. Then this has got 100th, this has got 100th as well. This has got 0,000th, this has got 2,000ths. And so 0.012 is not the smallest one. It must be 0.0102, and then 0.012, and then it must be 0.102, 0.102, and if I can squeeze that in, let's do that. Just put a bit more space between them. And the final one was, what was it? 0.0102, 0.012, 0.0, no, what am I saying? 0.12. 0.12, sorry, I got a bit mixed up when I did that last zoom. Okay, so that's what we have for the order, smallest to largest. Now, I think there's two questions. The bar model question and I think someone else question 6. So bar model question was, I think, question 4, if I'm not mistaken. Question 4 here. Okay, so here we go through this one and then we go through the other question as well. Question 4, excuse me. James shares his sweets so that every time Eva gets 1 part, Sophia receives 3 parts. You've got 3 parts here, 1 part for Eva and 2 parts for Trent. What we've said for this question is that because it says that Trent and Sophia have had 90 sweets more than Eva. So this is the part, this section here is the part that shows that Trent and Sophia have more than Eva, right? Because Sophia's got 2 bars more than Eva and Trent has got 1 bar more than Eva. And it says there that together, Trent and Sophia have 90 sweets altogether more than Eva. So those 3 equal parts must equal to 90 because they're 3 equal parts because the ratio. That must mean that each part must be 30, 60, 90. And so because each part's 30, all of those parts must be 30. And therefore, there's 1, 2, 3, 4, 5, 6 parts equal to 30 each. And therefore, 106 times 30 equals 180 sweets altogether. Okay, hopefully that made sense, Miss S.K. Gill. And I've got another question, which was going to go for question 6. Question 6, which is this one here. Question 6 really is thinking about the lowest common multiple here. Okay, so lowest common multiple of what was it? 8 minutes and 12 minutes is going to be 24 minutes. So every 24 minutes, who was it that asked that question actually? Rita. Every 24 minutes, Rita, they have every 24 minutes they get to the bus stop at the same time together. And so 24 minutes, then it's going to be after another 24 minutes they'll be at the same bus stop again together. Then after another 24 minutes they'll be at the same bus stop together. So we want to find out how many lots of those 24 minutes appear in 1 hour and 23 minutes, which is the time between 8:07 and 9:30. And so we worked out that 24 minutes appears once. So 8:07 add 24 minutes. That'll be the first time they meet again together at the bus stop. Then after 48 minutes after 8:07, they'll meet again. Then after 72 minutes after 8:07, they'll meet again. And that'll be it, because after that, it'll be 96 minutes, which is too much, which is more than the 1 hour and 23 minutes, which is equal to 83 minutes. And so they'll appear together in the same bus stop 3 times between 8:07 and 9:30 a.m. So hopefully that made sense. So I'm going to jump over to myself here and talk to you about this paper and make you understand what we have created and why we created this. So this is the CSSE Revision Mat 1, our first week of this summer holidays. Last year, we created 3 exam papers. Or was it 4? I can't remember now. Quite a few exam papers last year. And that was hard work, because it takes a lot of effort to create exam papers properly, okay? And so that's something that we didn't want to do again this year, because it is a big challenge and we don't want to let you down. We don't want to just create something that we know you can use and you might be grateful for it, but it's not great. Last year, we worked hard and made sure they were brilliant, and we had a lot of positive reviews. This year, we wanted to create something smaller, less of a workload for us, because it's holidays for us as well. But at the same time, beneficial for you. And that's where the revision mats came in. Revision mats are used in GCSE maths, and they're absolutely fantastic. So if you've got children in GCSE maths or year 10 and 11, use revision mats. Check out revision mats online. There's plenty out there. Some really good ones. Brilliant for your children in secondary. No one's created them for CSSE or 11 plus. Hence, we started creating them now because we feel it can have the same impact for your children's revision, rather than doing whole papers, which takes a huge amount of time. As you're building, you should do that. But as you're building up to those papers, you can use the revision mats as well, so that you can identify those weak points. So we're going to bring out another one tomorrow. Look out for that. If you have any kind of maths and science tuition needs, let us know. We would love to support you. As you can see, as Agnes has mentioned, I'm a bit of a geek when it comes to tech. I love using technology for our lessons in a very positive and impactful way. So, if your children are into maths or they're struggling with maths, whichever way, we would love to support your children. CSSE wise, we've got a new year 5 group starting in September. So if you let your family, friends, everyone know, I would be really appreciative, so that we can book them in and make sure they get the best math support they can do the next year. If you have any questions, feel free to ask away. And I would love to answer your questions. If you haven't, don't feel forced to ask any questions. If you've got somewhere to go, please do go. This will be This is recorded, so it'll be available after this session. So yeah, feel free to ask away. If I don't answer it on live video here, I would answer it by typing an answer afterwards. So if you're watching this recorded, don't be afraid to ask questions. I'm one of the admins of this group, and I support as many teachers, parents, as well as tutors as possible in their maths education. I train teachers for a living myself. So if you've got primary schools that are interested in Singapore maths, let them know about me, and we would love to support their teachers as well. I think that's about it. Asma asking how to get the free papers. It's in the files section, Asma. And if you just go down on the main page, on the main group page, you'll find lots of CSSE material that I've put up for free, and you can access them, including a Facebook Live like this, going through the past paper, so that you can also look at those solutions as well. I think that's about it from me. I think my series just suddenly opened up. I didn't want it to go away. I don't know why it's there. So I think I'm going to stop there. Thank you so much for attending, and I would love to see you in future sessions. Thank you, Agnes, for letting me do this as well. And the admins are brilliant in this group. They really work hard to give you the best they can for free. It takes a lot of our time as well to create, make, deliver these sessions. And so I'm sure parents will tell their friends and families about us, so that we can grow this group even bigger. and make sure that there are more parents that benefit from these sessions. I'll stop there and I'll see you next time. Take care, everyone. Bye.